pulsar, you think of perhaps a scientific phenomena throughout our planet universe. Might it be an object? Well, the spinning electromagnetized soup of superdense neutrons and electrons known as a pulsar is a lot more than the name portrays. Let me tell you a bit about what pulsars are and where they come from. The first known pulsar was discovered in the Cambridge Radio Astronomy Observatory by scientists Jocelyn Bell and Anthony Hewish in 1967. Once, when they were studying the night sky, the radio telescope picked up a reading that seemed to pulse and was strangely consistent and uniform. At once, public suspicion was that it was an extraterrestrial civilization. This theory was disproven by the strange discovery of more of these signals. The name pulsar is actually just descriptive of the illusion of a pulsar spin. But first, let me tell you what a pulsar is and how a pulsar is formed. When a large mass star goes supernova, collapses under its own gravity when nuclear fusion is no longer possible, if the mass is great enough, the iron will continue to fuse, and what is left is a soup of neutrons and electromagnetic fields that combine to form a huge magnetic field going through the pulsar. To understand pulsars, you first need to understand neutron stars. Neutron stars are collapsed stars in the form of a superdense soup of neutrons. Sound familiar? Well, it should. Pulsars and neutron stars are essentially the same thing. Pulsars are spinning because of the conversion of energy from the matter surrounding it, and like a figure skater with her arms pulled in, the more mass in the pulsar's gravitational field, the faster it will spin. The reason why a pulsar has a magnetic field is because of the pure liquid neutron core, or at least that is one theory. Electrons flow along the arcs of the magnetic fields. These electrons bump into photons of light and matter in the magnetosphere, or the space just around a pulsar, giving off waves from all over the spectrum. Because the neutron star is so dense, the pulsar's magnetic field is some trillion times the power of the Earth's. As mentioned earlier, the way radiation from a pulsar appears on a radio telescope reading would appear to be pulsing. But wait, you may say, earlier you mentioned that pulsing was an illusion. Well, it is because the magnetic field of a pulsar is consistent, and the pulsar has two different axes. The spin axis and the magnetic field axis are not the same, so it creates a sort of lighthouse effect, where if one magnetic field is pointed toward Earth and the pulsar is spinning, it appears to pulse. A term used by many astrophysicists for certain pulsars are millisecond pulsars, whose pulse happens every millisecond. This measurement for millisecond pulsars, and just pulsars in general, is not 100% accurate, because as pulsars age, their spin slows ever so slightly. On the other hand, as pulsars gain gravitational energy from orbiting matter or from the gravity of a binary system, in which a pulsar orbits with a star, a white dwarf, or even another neutron star. Pulsars can also be found in nebulae, such as the Crab Nebulae, in which the Crab pulsar accounts for most of the nebula's radioactive output. Despite all we know about pulsars, all we have observed and taught ourselves, there are still a few unanswered questions, like what happens to a pulsar when it finally loses energy from its spin? Or what exactly makes up the core of a neutron star? These are the questions that give the study of pulsars meaning, yet these are things that only the future research and technology can tell. You might ask yourself, why does the study of pulsars have significance to us humans on the edge of just another spiral galaxy in the great universe? The study of pulsars adds to our understanding and influences our perception of the universe. Being the universe and the universe being us gives significance to the study of anything in the reaches of space. Scientists find meaning in it for more detailed theories and proving just as many. The questions, they give pulsars meaning. The unsureness, they give pulsars meaning. The inquiry, they give pulsars meaning.